Hello students, today we are going to discuss about the structure of glucose and its functions. Earlier we already discussed about the classification, definition, etc. Now the monosaccharides, glucose Part 2. Glucose structure and its functions. Physiologically, glucose is a most important monosaccharide. It is a main sugar of the body. Tissues of the body use it as energy source. The form of sugar in the blood is D-glucose. Structure. The molecular formula is C6H12O6. For better understanding the structure of glucose, let us consider the formation of hemiacetals. An aldehyde reacts with alcohols. It has an aldehyde group at C1 and it contains 6 carbon atoms, hence it is named as aldohexose. It forms pentacetyl compound on acetylation, indicates the presence of 5 OH groups. No 2 OH groups attached to the same carbon atom, hence it is stable sugar. Now the D-glucose structure. D-glucose has the CHO at first carbon, second carbon the OH is on right side, on third carbon the OH is on left side, and fourth carbon OH is on right side, and fifth carbon OH is on right side, sixth carbon is primary alcohol CH2OH. If the OH is on right side of fifth carbon, that is a penultimate asymmetric carbon. That indicates the D form of isomer. And its mirror is a L isomer. Both D and L isomers are geometrical isomers. The presence of OH group on the right side of the fifth carbon atom is named as D-glucose, and OH on the left side of the fifth carbon atom is named as L-glucose. Both D and L are mirror images. They are 4 asymmetric carbons, second, third, fourth, fifth. If 4 covalent bonds of carbon atom is satisfied by 4 different groups, is named as asymmetric carbon. Optically active and number of isomers depend on number of asymmetric carbons. The number of possible isomers is 2 power n. N is number of asymmetric carbon atoms present in the glucose. The above open chain structure is unable to explain the following. Number 1 is meta rotation. Number 2 is formation of compound with sodium bisulfite. Number 3, formation of 2 isomeric methyl glucosides with methyl alcohol. 4 is no restoration of color of Skipp's reagent. So to explain above facts, Emil Fischer and Howard gave ring projections to glucose. They are depicted by 6-membered ring pyranose, that is pyron, or 5-membered ring furanose derived from furan. Monosaccharides in solution mainly present as ring forms. Aldehyde group at C1 is react with hydroxyl group of the same molecule to form hemiacetal linkage. Due to this, C1 changes to asymmetric carbon named as chiral. The linkage is formed between C1 and C5 is called D-glucopyranose. The linkage is formed between C1 and C4 is called as D-furanose. When analyzing the ring structures, you have observed that the OH group at the bottom on the first carbon indicates the alpha D glucopyranose. The OH group on first carbon projected upward direction, it is named as beta D glucopyranose. The OH group on the same side of the MS-type linkage is at C1 named as alpha isomer, and OH group is on opposite side of MS-type linkage is named as beta isomer. The number of isomers for a open chain form of glucose is 2 to the power of 4, that is equal to 16. The number of possible isomers for a cyclic form of glucose is 2 to the power of 5, that is equal to 32. Sources of glucose. Starches derived from cereals like corn starch, vegetables like potato starch, fruits like grapes, and cane sugar, that is sucrose containing glucose and fructose, milk sugar, lactose contain glucose and galactose. Properties: it is a carbohydrate since it answers Small's test. Reducing sugar since it reduces Benedict's reagent and Fehling's reagent. It is a monosaccharide since it gives red scum with barphoids. It forms ozones with phenyl hydrazine hydrochloride and acetic acid. The shape of the ozone is clusters of needles. Glucose on oxidation with bromine water, mild oxidizing agent, forms gluconic acid. CHO oxidized to COOH. Glucose on oxidation with concentrated nitric acid gives saccharic acid. Both CHO and CH2OH oxidized to COOH. It is oxidation with hydrogen peroxide and gives glucuronic acid, that is 6th carbon CH2OH oxidized to COOH. It is a dextrorotatory. Optically active since the presence of asymmetric carbon atoms. Its mutarotation depends upon type of ionomer. Alpha isomer shows plus 18.7 and beta isomer shows plus 112.2. Functions. It is a primary source of energy for human beings and animals. It is a component of sucrose, cane sugar, and lactose, milk sugar. Excess glucose in tissue and liver converted into glycogen and stored as a reserved carbohydrate. Alpha D glucose is present in blood and CSF. Brain requires glucose for energy source. In absence of glucose, it uses ketone bodies as its energy source. Thank you.